Hi everyone, in the first video we were talking about how to name and maybe even deduce the name from the chemical formulas of binary ionic compounds. Now what would happen if we have binary covalent? So our learning target for this video is for us to apply the IUPAC rules in naming and writing chemical formulas of binary covalent compounds, or for simplicity's sake we call them type 3 binary compounds. Okay, so as a review, binary compounds are those composed of two types of elements, okay, such as water and KBr, that's potassium bromide, but not necessarily just two atoms. So for this lecture, we will be focusing on binary covalent or molecular compounds, which are composed of both nonmetals, okay, like H2O, CO2. Okay, so here are the rules for naming binary covalent compounds or type 3 binary compounds. Okay, first you must look at that they are both nonmetals. Okay, so by now you must know where the nonmetals are in the periodic table. So the first element in the formula is named and the full element name is used. Okay, so the second element is named as though it were an anion. Okay? Prefixes are used to denote the numbers of atoms present, and the prefix mono is never used for naming the first element. Right? So here are the different prefixes that will be used to indicate the number of atoms. Okay, so if there's only one, and this only happens for the second element, if there's only one, we say mono, and then two is di, three is tri, tetra, penta, hexa, hepta, octa. I'm pretty sure you are familiar with these Greek prefixes because you use them to name your polygons also. So for example, if you have a polygon with 10 sides, you say decagon, right? And the list goes on to undeca, 11, dodeca, trideca, tetradeca, okay, until you reach icosa. But maybe for now, we will focus on the first 10 prefixes. Okay, we will be using mostly the first 10 prefixes. So here are a few examples. So take note that you have to look at whether the binary compound, the composing elements are both nonmetals. Okay, and that's the time you use the Greek prefixes like mono, di, tri, right? So for example, CO2. Okay, there is only one carbon as the first element, but in the first element you do not say mono, right? Only for the second element. So that gives us carbon dioxide. Okay, carbon dioxide. The second example is the one where mono is used, so carbon monoxide. Okay, and then since there are two O's together, then we just drop the second O. So you do not say monooxide, but monoxide, carbon monoxide. PCl3, that's phosphorus trichloride. Phosphorus trichloride. CCl4, that's carbon tetrachloride. Okay, carbon tetrachloride. N2O5, that's dinitrogen pentoxide. Okay, so we drop the A in place of, we drop the A if we have adjacent A and O's together. So we do not say pentaoxide, we say pentoxide. This one is carbon disulfide. Alright, carbon disulfide. So here are a few more examples. So you have sulfur hexafluoride and dinitrogen tetroxide. Okay, just very easy topic. So what is the name of the compound SeO2? Okay, so answer is selenium dioxide, right? So selenium here acts as is our nonmetal. Okay, so maybe a flowchart to help you so you can distinguish and uh, have a systematic way of thinking. So if you see a compound, you try to ask whether is it a binary compound, yes or no. So how do you know if it's binary? If it is made up of two kinds of atoms. And then you ask, is a metal present? So if it's yes, so does the metal form more than one cation? So if it's yes, then you use the rules in naming type 2 binary compounds, wherein the feature there is you have to use the Roman numerals to indicate the charge or to specify the charge. If the metal does not form more than one cation, then you just use the name, the element name for that cation. All right. And then if there's no metal present and you see that it is a binary compound, it's mostly non-metals. So we go to the rules in naming type 3, but type 3 binary compounds, which are using prefixes. All right. So in the next video, we will be talking about the IUPAC rules in naming and writing the chemical formulas of ternary salts. Okay, but for now, you can take a break or you look for more examples.